Chapter 8 is about work and power. When a force moves an object, it does work, and energy is transferred to the object. Amount of energy transferred in joules is equals to work done, and the unit is joules. Example: a man applies a force to move the material. He transfers 600 joules of energy. Only a portion of this becomes useful work on the substance, while the remainder is dissipated to the surroundings as thermal and sound energy. Work occurs when force causes an object to move. If the force is larger or the object is moved a bigger distance, then a greater amount of work is carried out. During this process, energy is shifted from one store to another because doing work always involves transferring energy. Work done is equals to force times distance. W is equals to F times D. Work is measured in joules. Work done is equals to force times distance. Example: if 7 Newton force moves an object a distance of 5 meter, so we can calculate the work done. 7 times 5 is equals to 35 joules. So definition of work is equals to force times distance. We can move the variables to find out the other two. For example, if we want to calculate work, we have a formula: W is equals to F times D. If we want to calculate F, then D will go to the another side and divide, and we can calculate F. Similarly, if we want to calculate distance, then D will go to the another side and divide, and we can calculate F. If we want to calculate D, then F will divide with W, and we can calculate D. Efficiency formula: useful energy output divided by energy input times 100% will give you efficiency. So this is an output and this is an input. So 30 divided by 100 times 100% will give you the efficiency, which is 30% in this case. There are other energies, input and output are given, which can also be practiced for the exam. Power describes how quickly work is carried out. Its measurement unit is watt. 1 watt means 1 joule of energy is transferred every second. Power is equals to amount of work done divided by the time taken to do that work. This definition is important for exam perspective. A power of 1000 watt is the same as 1 kilowatt. Some examples of common power outputs: householding machines, trained athlete when exercising. Example: a student climbs a staircase 40 times in 4 minutes. Each climb raises their body weight of 50 kilo through a height of 0.4 meter. If we need to calculate the power output, first step, we will convert this time into seconds. So we have actually 240 seconds. Then we will calculate the work done, which is force times distance. Force, we know that is equals to weight, and weight is equals to mass times gravity. Mass is given in our question 50 kg, and this is the constant value for gravity. We times it and we get 500 newtons. Total distance is 40 climbs times 0.4 meter, which means 16 meters. So now if we want to calculate work done, we will simply do F times distance. F is 500, distance is in meters, 16. We times it and we will get our work done. Now we want to calculate power. Power formula is work done divided by time taken. Work done, we already found it here. 8,000 divided by 240 seconds that we found up. So altogether our power is 33 watts. Example number 2, a builder lifts 25 bricks in 2 minutes. Each brick has weight of 30 Newton and is lifted 1.2 meters. Find the power. Step number 1, convert minutes into seconds. Step number 2, calculate the work done. 25 times 30, which is force times distance. Now work done is 750, which is force times the distance, which is 1.2. We will get the work done 900 joules. Then we need power output, work done divided by the time, and we will get the power output. This is weight. Okay. Next example is a cyclist pedals up hill raising their 65 kg body by 10 meters in 50 seconds. Calculate the cyclist's power. First step, time taken 50 seconds. Step number 2, work done. Force is equals to mass times gravitational force. Mass is given 65 times gravitational uh, value, constant value, we get 650 Newton. Then distance, we have 10 meters, work done, distance times the force. Then we have power, work done divided by time. So we will get 130 watts. Example number 4, a crane lifts 200 kilogram crate up 5 meter in 15 seconds. Calculate the crane's power. First calculate the time, work done 2000, then distance 5 meter, work done, we got it 10,000 joules. Then power 10,000 divided by 15 and we get the power 670 watts. Similarly, example number 5, a person pushes a trolley with the force of 150 Newton for a distance of 12 meter in 30 seconds. We need to find the power. Time is given. Work done we need to calculate, and the last step to calculate the power. With this we have finished our chapter. See you in our next chapter.